Welcome to my classroom. The idea of using mass point is a wonderful technique for solving geometric problems, even though it is not included in the teaching syllabus in Hong Kong. I will use several videos to introduce this topic. This is the first video for the basic techniques of mass point for students at all levels. Let me start with a problem which can be solved by the knowledge learned in the syllabus. It is good for you to solve the problem first so that you can appreciate more the idea of mass point which I discuss later. So, pause the video and solve the problem. You may count the time used for the working as a reference later. Let the given ratio be R to 1 and 1 to S, and the area of triangle AFG is denoted by A. For equal height, the ratio of area is equal to the ratio of base. The area of BFG is SA. Area of ACG is RA. Add up the two triangles and the area of ABG is 1 plus SA. Using the given ratio 3 to 1, we have the area of triangle BDG, which is 1/3 of 1S plus A, and area of CDG is 1/3 of RA. Consider the triangles AGC and BCG, which share the same base. The ratio of the areas is equal to the ratio of their heights, that is 1 to S. Substitute the previous results. We have the first equation in R and S. Similarly, using the other given ratio 6 to 5, the area of AEG is 5/6 of 1 plus SA. By subtraction, we have the area of CEG. Consider triangles BCG and CEG, which share the same base. The ratio of the areas is equal to the ratio of the height, that is 6 to 5. So that the second equation in R and S is established. By solving equations 1 and 2, we have S equals to 11/20 and R equals to 13/1/13. That is, CG to GF is 13/1/13 and AF to FB is 20/11. The answers are obtained. The solution is not really complicated, but you need to have a clear mind to see the relationship between the ratios of size and areas. We are going to develop other techniques which can solve this type of problems in a much quicker way. The idea of mass point starts with a simple physical principle. Consider a word which is mass negligible. Two masses, MA and MB, are placed to the two ends A and B of the word as shown. The system is in equilibrium when the supporting point is placed at P, such that MA times DA equals to MB times DB, or in the ratio DA to DB equals to MB to MA. The location at P is regarded as the center of mass of the system, and it bears with the total mass MA plus MB. Using this principle, we can solve some geometric problems in an easy manner. Let me start with an example that we know quite well. That is the centroid of a triangle. Consider a triangular plane with the uniform density and mass negligible. We would like to locate the centroid G, which I discussed in my previous video. It is the center of gravity, or the center of mass. To find G, we assign the mass of 1 to each vertex. Consider the side BC. As the ratio of mass is 1 to 1, the ratio of distance is also 1 to 1. That is, the center of mass of BC is at the midpoint M with a mass of 2. Now, consider the median AM. The ratio of mass is 1 to 2, so the ratio of distance is 2 to 1 by the principle. That is, AG to GM is 2 to 1. That is what we know about centroid. This principle can be applied not only to plane figures, but also to 3D solids. Let me use a regular tetrahedron for illustration. Here, O is the center of tetrahedron. That is, O is equidistant from all vertices. As the tetrahedron is regular, O is also the center of mass of the figure. Find angle AOB. Again, it is good for you to pause the video and find the angle with your knowledge on trigonometry first. The problem can be solved by considering the volumes of the tetrahedron. Here, I solve the problem by mass point. As the tetrahedron is regular, the line joining A and O meets the base triangle at its centroid G. Since regular and looking for angle, let me assume the length of each edge is 1 and assign a mass of 1 to each vertex of the tetrahedron. Then the mass of the base triangle BCD at G is 3. Consider the line AOG. The mass at A is 1 and the mass at G is 3. Thus, AG to GO is 3 to 1. That is, AO equals to 3 over 4 AG. Consider the median from D. We get GD by Pythagoras theorem, which is 1 over root 3. Consider triangle AGD. We have AG equals to root 2 over 3. In other words, AO equals to root 3 over 8. Due to symmetry, BO also equals to root 3 over 8. Consider triangle AOB by cosine formula. Cosine theta equals to negative 1/3. Thus, angle AOB equals to 109.5 degrees. I suppose you have already got the idea of the principle of mass point. Let me use mass point to solve the initial problem again. This problem is different from centroid of triangle and regular tetrahedron that the mass of the vertex is 1 and use the structure of the figure to find out the ratio of the lengths. In this problem, on the contrary, we are given the ratio of the lengths and we are asked to find the ratio of the other pairs of lengths. In order to use the principle mentioned above, we assign suitable masses to the vertices to fit the given ratios. As AG to GD is 3 to 1, we have MA to MD equals to 1 to 3. So, we assign a mass of 1 to A and a mass of 3 to D. Then, the mass of G is 4. Since BG to GE is 6 to 5, and the mass of G is 4, the mass of B equals to 5 over 11 times 4, that is 20 over 11. And the mass of E equals to 6 over 11 times 4, that is 24 over 11. Thus, the mass of F equals to 1 plus 20 over 11, that is 31 over 11. And the mass of C is 3 minus 20 over 11, that is 13 over 11. Or 4 minus 31 over 11. Still, we get the same answer, 13 over 11. Therefore, CG to GF is 31 over 11 to 13 over 11, that is 31 to 13. And AF to FB equals to 20 over 11 to 1, that is 20 to 11. The answer is same as what we got previously, but in a much faster way, right? Perhaps this is a new method to you. It is good to pause the video and work it again on your own to make sure you understand the idea and techniques behind. Let me use another example to strengthen your understanding of mass point. In this question, we are given areas of triangles with the same height. Thus, the ratio of the lengths can be obtained and the ratio helps us assign masses to the vertices for calculation. Consider triangle BFG and triangle AFG. They share the same height. Thus, BF to FA equals to 3 to 4. Assign a mass of 3 to A and a mass of 4 to B. Now, the ratio of the area of triangle ABG to BDG is 2 to 1. Since the two triangles share the same height, we have AG to GD equals to 2 to 1. That is, MA to MD is 1 to 2. Since the mass of A is 3, then the mass of D is 6. Consider the side BDC. The mass of C equals to 6 minus 4, that is 2. So, BD to DC is 2 to 4, that is 1 to 2. Therefore, the area of triangle ABC equals to 40 plus 30 plus 35 times 3 over 1, that is 315. For this simple example, the answer can be obtained without the help of mass point. You may try and compare the methods. Here is a problem for your exploration. You may try with and without the use of mass point. Wish you enjoy.